This is episode 4 of a 5-part series meant to go over 2 proposals to make new buildings cleaner and more energy efficient. Thanks for continuing on. My name is Hugo Wong and I work at the Building and Safety Standards Branch, the part of the Government of British Columbia responsible for building codes and standards. This episode covers the energy efficiency and greenhouse gas proposal for Part 9 residential buildings, otherwise known as small buildings like single-family homes, row houses, and the like. Let's start with some definitions. A Part 9 building has a footprint of less than 600 square meters and is 3 stories or less in height. They're called Part 9 buildings because the requirements are in Part 9 of the building code. Although the code changes will by necessity go into pretty significant technical detail, there are some guiding principles where, if you keep them in mind, you'll be steered true. Although episode 2 went into this in more detail, I'll give a partial recap here. The first is to collaborate early, sometimes known as an integrated design process. That means getting everyone together, including trades, designers, owners, energy advisors, etc., so their expertise can be leveraged from the start. Next, once they're together, design for efficiency. An energy-efficient design has windows and doors in strategic places, adequate ventilation, good insulation, and heating and cooling capacity that meets but doesn't exceed the needs of the home. During construction itself, mind the details so there are fewer thermal bridges and air leaks. Seal those air leaks up and watch your corners, junctions, gaps, and studs to reduce thermal bridging. Don't let heat get conducted out of the house. Here's a summary of the proposed changes for Part 9 buildings. The first is a new prescriptive option for Step 3 only. The second is a series of smaller changes for both harmonization with national codes and additional airtightness testing options aimed for builders of smaller homes. The third is the opt-in building carbon pollution standard. Before discussing the differences, I want to clarify what's staying the same. Existing performance-based metrics for steps 3 to 5 are mostly unchanged. There are some minor changes to the metrics, along with some shuffling of tables and new wording to harmonize with the National Building Code. The name of Step 3 and where those requirements are in the code may change, but any builder currently building homes to steps 3 to 5 should transition smoothly to the new requirements, as the techniques and designs are still applicable. For builders building to the base building code, or steps 1 or 2, those compliance paths will be reserved, which in building code terminology makes them unavailable for use, as they will no longer meet minimum energy efficiency requirements. The performance-based requirements, we believe, will be the most cost-effective in most cases when compared to the new prescriptive option. Labor market studies, surveys, and conversations with industry have informed us that energy advisors or modelers are available in the most well-populated areas of BC. That means EAs or modelers are available to work on most new construction in BC for a relatively affordable rate. However, we know that that's not the case in every region, which is why we've developed a prescriptive path to achieve approximately 20% better energy efficiency in new buildings. This prescriptive option is primarily intended for communities that don't have ready access to energy advisors. Northern and remote communities have told us that they have different levels of access to EAs and some high-performance building materials. Most urban centers in BC have access to energy advisors nearby, but in some rural communities it can be expensive for energy advisors to travel long distances to perform airtightness testing. Communities like Haida Gwaii, Saturna Island, and Dease Lake can take time to travel to, even if some of them aren't that far geographically from urban centers. That's why we're proposing a prescriptive backstop for Part 9 buildings. Builders following this prescriptive path will notice the requirements will be more stringent than current base code requirements. More insulation and more energy-efficient windows and doors will be required, along with mandatory heat recovery ventilators, or HRVs, that operate at higher efficiencies than current base code minimums, with an option to use a heat pump instead of an HRV to lower the home's overall energy use. These changes to walls, fenestration, and equipment are designed to improve energy efficiency by approximately 20%, without the need for an energy model or airtightness testing. Builders who are concerned about the potentially high travel costs for an energy advisor can see if this option is right for them. Despite the new prescriptive path, the existing performance-based path will be the easier, more affordable option for most builders, particularly in places with many energy advisors close by. We strongly suggest builders do a cost-benefit analysis before using the prescriptive option, because in many cases, the performance option is more cost-effective while achieving the same energy efficiency goal. Our hope is that in time, more energy advisors will service northern and remote communities, making the performance path cost-effective for them as well. To reinforce this, steps 4 and 5 will remain performance-based only. This is just for the labor availability and training to catch up. We still want to emphasize the performance path. These clippings from the code proposal show the new prescriptive values being considered. Notice the higher values in most columns compared to the existing 2018 BC Building Code. Please look over the actual code proposal to examine all the figures. Before moving on, I wanted to address 2 building types that won't be part of the current energy efficiency proposal. We've heard that log homes and smaller homes in cold climates have difficulty achieving energy efficiency improvements despite following all the recommended building approaches to improve efficiency in a cost-effective way. We're conducting research right now in collaboration with industry to see how we can achieve comparable energy efficiency improvements at the lowest cost. This may result in different performance or prescriptive values for these buildings, but that information is not available yet. So in this proposal, log homes and smaller homes in cold climates will not be expected to meet the performance or prescriptive requirements for other Part 9 buildings. We'll continue the technical research in this area, and we'll update building code users when a solution and code language are ready. Moving on, there are few smaller technical changes happening to Part 9, which I'll quickly go over. The new NLA and NLR air tightness testing methods will make it easier for smaller buildings to meet air tightness requirements, because regardless of attention to detail, ACH was a hard method for small buildings to meet, yet quite easy for large buildings, comparatively. In a first step towards harmonizing with the National Building Code of Canada, we are reformatting some of the tables within the BC Building Code for the % better compliance path for Energy Step Code. This is not adoption of the national points-based approach, but mainly a matter of reformatting. Previously, the % better and absolute values were in the same table. Now, they're in separate tables, as they have the NLA and NLR air tightness testing, which we got from the National Model Code. There are also some new % better targets that differentiate between house size and a new energy performance improvement compliance calculation methodology as well. Those are also from the most recent National Model Code. So check out the draft code language for more details. Finally, a building carbon pollution standard is being proposed for Part 9 residential buildings. It'll be structured similarly to the Energy Step Code, so concepts will be familiar here. It'll have 4 levels: measure only, medium, low, and zero carbon ready. Although there are performance and prescriptive options, we did a significant amount of modeling and research and set the specifications such that buildings can generally meet these levels by gradually decarbonizing major systems. So, buildings that meet the medium level typically have one major system decarbonized, so either domestic hot water or heat. Buildings that meet the low level have domestic hot water and heat decarbonized, whereas the zero carbon level requires all systems to be decarbonized. I want to bring up an important distinction. You'll see throughout the code proposals that the phrase zero carbon ready rather than zero carbon is written. Now, are they different goals? The short answer is no. Building codes regulate buildings, not the energy sources that go into them. Utility providers and other parts of government are responsible for requiring and supplying lower carbon fuels to these buildings. In short, we as building code writers make buildings ready for zero carbon fuel. Utility providers and other parts of government provide the zero carbon fuel to finish the job. If the plan includes on-site renewable energy like solar for a portion of energy consumption, that's factored in too. Before we get too far, I just want to clarify again that this proposal only covers operational carbon. It does not address embodied carbon, which accounts for emissions from all parts of the building's life cycle, from manufacturing of the components to deconstruction. You'll notice that the implementation of the proposed carbon pollution standard is quite familiar. That's because it was modeled after the approach of the BC Energy Step Code. Local governments can choose the requirements for their community, and builders can meet or exceed those local requirements. And province-wide requirements are expected to increase over time to meet a provincial target, which in this case is zero carbon new construction by 2030. The difference is that instead of walls, windows, insulation, and other aspects of building design, the Building Carbon Pollution Standard influences the kind of equipment and energy a building uses. It's flexible enough to account for different types of equipment and energy, but it does influence that choice. Local governments may reference GHG levels for buildings in their community in addition to the BC Energy Step Code in their bylaws or development permit authorities. Some communities have introduced a step-up, step-down approach for local builders, where the base energy efficiency requirement is high, but it could be relaxed if a low-carbon energy system were installed. While this incentive structure can continue under the provincial code proposal, we're providing additional tools to local governments to require carbon pollution reduction in buildings and create options for those who want to include dual fuel solutions. As a reminder, any technical building requirements, including any carbon or energy efficiency related requirements that conflict with the new Building Carbon Pollution Standard, will have no force or effect if this code proposal takes effect. I'll quickly recap some key terms I went over in episode 2. We use a common figure called CO2 equivalent, or CO2e, to represent the multiple types of greenhouse gases emitted from burning fossil fuels. It accounts for their different warming effects and life in the atmosphere. Building emissions will be measured using two metrics: greenhouse gas emissions on an annual basis in kilograms, called total or absolute GHG, and the kilograms of CO2e emitted per meter squared of heated floor area, called greenhouse gas intensity, or GHGI. The reason why we're using both will become clear in a moment. Finally, an emissions factor is assigned to each type of energy that's used in the building. It estimates how polluting each energy source is. There will be a lot more information on this in just a bit. We're proposing a hybrid approach for Part 9 buildings, which uses both total GHG and GHGI, instead of just relying on one or the other. We felt each had their pros and cons, so using both would give us the best of both worlds. For example, GHGI targets are relatively easy for medium and large dwelling units to meet, but quite hard for small dwelling units to meet. Total GHG targets, on the other hand, are easier for small homes to meet, but medium or large-sized dwelling units would have a hard time even if they only used a grid-scale, low-carbon energy source. What we're proposing is not exactly the straight 631 GHGI approach that's already in use in some areas, but rather one that creates a base GHG allowance for each dwelling unit. If the unit falls under the base allowance, great. We did the modeling and set the allowances such that most small homes could meet them. That provides a decarbonization target that they can meet. Medium and large dwelling units are unlikely to meet these base allowances, so there's a path for them too. Buildings that exceed the base allowance must not exceed a GHGI target by floor area, and they also have to fall below an emissions cap. Let's dig into that a bit. These are the greenhouse gas tables we're putting out for public review for Part 9 residential buildings. The GHG emission compliance options would be applicable to any size Part 9 residential building, but the choice of compliance option would be heavily influenced by the size of the home. The numbers have been set so that small homes would most likely be built to the column with the entries 1050, 440, and 265. Medium and large size homes would meet the GHGI of either 6, 2.5, and 1.5, and would be restricted from emitting any more than 2,400, 800, or 500 kilograms of CO2e per year, depending on the GHG level chosen. You can also see a prescriptive backstop for Part 9 GHGs in the column on the right, which is in part to recognize that homes that follow the prescriptive path for energy efficiency won't have modeled GHGs. Yet it can be an effective way for places with few energy advisors to lower their emissions too. Our modeling has shown that this will generally result in the desired outcome. There are a lot of technical details that will be relevant to building designers to ensure the building complies with the requirements. These are some of the high-level points. The word house is a defined term, which includes a main dwelling unit and, if applicable, a secondary suite. The term house can also mean a unit of a duplex or a two-bedroom unit of a small apartment building. If a building has more than one dwelling unit, each dwelling unit is to meet the specified emissions requirements. The whole building will be modeled, but the targets are for the units, not the whole building. The Building Carbon Pollution Standard does not regulate so-called luxury loads, such as hot tubs, pools, and heated driveways. Some local governments may wish to explore other methods of reducing the energy use of these luxury loads, including using their development permit authorities for energy conservation and GHG reduction. This is a very high-level summary of the details that go into evaluating the carbon pollution of a home. The details will be in a modeling rule set which is currently being developed. But for some more information about assumptions and modeling, take a look at the data sheets included in the supplementary material. On the topic of energy modeling, it may be useful to go over how modeling and other energy sources are included in the Building Carbon Pollution Standard. As a note, this slide is identical to the slide on the same topic in the Part 3 buildings presentations. So if you've seen or listened to that one, just skip ahead a little bit to the next slide. Measuring carbon emissions from buildings requires a set of energy modeling guidelines, which describes how emissions intensive each energy source is. In other words, it assigns an emissions factor for every unit of energy. For example, 0.011 kilograms of CO2e per kilowatt hour. These factors are a snapshot in time and are a sophisticated estimate, but they don't always reflect the true emissions of an energy source because emissions can fluctuate. For example, most electricity customers in BC are connected to the integrated electricity grid, which is supplied mostly by hydroelectricity and at least 93% clean by legislation. But there are times when emissions change if the utility purchases higher carbon energy to supplement the hydroelectricity supply when customers are using more power. Although there are plans to make the integrated grid 100% clean in the coming years, the emissions factor still fluctuates as of August 2022. Our partners in the building sector have told us, however, that a stable and predictable building code, where specifications remain the same for several years at a time, are important because buildings take years to design and build. If requirements changed all the time, design and costing estimates would change too. So, to provide some certainty and stability for builders when utilities are rapidly decarbonizing, the proposed Building Carbon Pollution Standard will base its performance levels on emissions factors set by the City of Vancouver's energy modeling guidelines. We're doing that because this approach is already in place in many BC communities, so it's familiar to the industry, and it'll help them transition from existing local GHG policies without the sticker shock of different GHG values from what they're used to. Although there are many ways of calculating emissions factors out there, we're proposing this approach because we think it is the most straightforward way to influence choices during the design and construction phase. As utilities decarbonize, the actual emissions of buildings will decrease, and when their emissions settle, we can see if this approach needs to be revisited. Because we're more interested in influencing building decisions as opposed to accurate emissions accounting after the building is built, we're proposing to use a single set of emissions factors for electricity, regardless of whether the building is connected to the integrated grid or the Fort Nelson grid, which has substantially higher emissions. We know that this approach will not accurately represent emissions from building operation in the Fort Nelson area, but it does provide a simple way for builders and clients in that area to make choices about how to decarbonize their buildings during construction, such as the equipment they install or the shape or orientation of the building. The granular details needed by design professionals will be in a modeling rule set, which is currently in development, so stay tuned for that. On the gas side, there are also big efforts to reduce carbon intensity. There is significant interest in renewable natural gas, or RNG, as a way to decarbonize the conventional natural gas supply. Also known as biomethane, it's a refined form of biogas, which comes from landfills, oil production, agriculture, sewage treatment, and other activities where biogas would otherwise be released into the atmosphere and contribute to climate change. As of August 2022, a proposal from FortisBC to introduce RNG at scale is currently before the BC Utilities Commission, or BCUC, which is an independent agency of the provincial government responsible for regulating British Columbia's energy utilities. The BCUC has not issued a decision on this proposal yet. So, given these variables, this draft code language is written to include future energy options, and terms like decarbonized fuels were chosen specifically to account for the breadth of possibilities. However, given the urgency of climate change, we are choosing to issue a code proposal now, so builders and local governments can start using it at scale. And when a decision is released, we will read it closely and assess if and how it affects the code language. Regarding district energy systems, which distribute thermal energy like steam to multiple buildings in an area or neighborhood, we think there's too much variability in specific systems used in BC for any single solution, as emissions vary by the fuel source of these systems. That flexibility is what makes district energy so attractive, but it does pose some challenges when trying to create a provincial solution. We've heard that local governments prefer to leave any decision of emissions factors between them and the district energy provider. So that's what we're proposing. It's consistent with the City of Vancouver's energy modeling guidelines too. This wraps up episode 4. The next episode, which concludes the series, summarizes some practical suggestions for different sectors, designed to increase the chances of a smooth rollout for everyone involved. See you there.